Sorry for that little pause. We're going to continue with 6.2. So a problem arises when we have a term in the equation that is negative. We cannot easily use balances, but we can still use algebra tiles to model it. So these are the tiles that we would have been using last year, and while in class they are green and white and red. In your textbook they are yellow and red, so these are the ones that I put in for this example. So we use the same principle of balance by adding the same tiles to each side or subtracting the same tiles from each side. So when given an equation like negative 3c plus 7 is equal to 2c minus 8, we can clearly see that it is being, step one is that we are modeling it. So we have negative 3c's, positive 7 constants, 2c's, and negative 8. So add two negative c tiles to each side to get the terms containing c on the same side and remove the zero pairs. So what we are doing is they have decided to get rid of these two yellow tiles, so they're no longer over here and only on this side. So to get rid of them, I'm doing the opposite, and the opposite of positive 2c is minus 2c. That gives me zero pairs and they go away. But on this side, when I add the negative 2c, they just get added because they're not zero pairs. Your next step, add 7 negative 1 tiles to each side to get the constant terms on the same side. So once again, we need to do the opposite of what is there. Because our variable's on this side, I have to do the opposite of the constants on this side. Because if I did the opposite of what was on this side, I would have had nothing left over here. And it's not possible to balance something if you don't have anything left on one of the sides. So the opposite of your positive 5 is negative 5, and what we do to one side, negative 7, because these are down here, negative 7. What we do to one side, we do to the other, so you can see that we have added in negative 7. So your last thing is to arrange the remaining tiles on each side into 5 groups. So 1, 2, 3, 4, 5, and I've split all of these left into 5, which means that in each individual grouping, there is 3 constants, and because they are red, they are all negatives. Now, just like we had done previous years, we do not want to have a negative exponent or a negative variable in the end, so we have to flip it to its opposite, and if we flip one side, we have to flip the other to its opposite as well. So here's an example of what the images and the tiles can look like. However, we can also still solve it algebraically. So I'm going to go back up to the board again so I can write to make it a little bit clearer. I'm sorry if my audio is a little bit distorted. So in this case, I'm going to do the opposite of what they did, and I'm going to get rid of the smaller amount of variables, which is actually the negative. And this way I don't have to work with negatives in the long run. So the opposite of negative 3c is positive 3c, and what I do to one side, I do to the other. 7 is equal to 5c minus 8. The opposite of minus 8 is plus 8. What I do to one side, I do to the other. 15 is equal to 5c. Opposite of multiplying by 5 is dividing by 5. What I do to one side, I do to the other. 3 is equal to c. Equations with rational numbers in fraction or decimal form cannot be modeled easily with balanced scales. However, we can solve these equations by doing the same thing to each side of the equation to isolate the variable. So that means we may add the same quantity to each side, subtract the same quantity from each side, multiply or divide each side by the same quantity. So solve each equation, then verify the solution. Okay, so when we have a question that looks like this first one, this minus or this 122 divided by r equals 3, this makes us go back to remembering things. Like if I had 12 divided by a question mark and it equals 4, do you know what that question mark is? Okay, so you should know that 12 divided by 3 is equal to 4. Do you also know that 12 divided by 4 is equal to 3? Which means that I can interchange these two numbers in a division and still get the correct answer. So I would actually interchange those two numbers my equation to get the correct answer. So now all I have to do is say 122 divided by 3, which isn't going to be a pretty number. It's going to give me 40.6 repeating, so 2/3 left, is equal to R. Okay? Second version of what we're going to do is we're going to solve this with the fractions. So if it is a fraction question to begin with, they do expect you guys to leave them as fractions and not necessarily convert them to decimals right away. So it is important that you guys know how to solve it with fraction style. So I would encourage all of you guys to actually attempt to do them as fractions, not just using your calculators to help you out. Okay, so when we're working with fractions, we know that we have to have common denominators when we are adding or subtracting. So I'm just going to start by giving these common denominators by cross multiplying by the opposite denominator to get my new numbers. So I'm going to have 10a, not 10 over a, 10a over 15 is going to be equal to 12a over 15 plus 8. So I need to have all of my variables on the same side, and I'm moving the variable, so the opposite of positive 12a over 15 is minus 12a over 15. When I do to one side, I have to do to the other. I'm left with negative 2a over 15 is equal to 8. Okay, now I don't necessarily have to continue to use this only as fractions, but I can do it in my 2 steps. Normally when I have a number on top of something like this, that means it is a division. So I can do the opposite. So the opposite of dividing by 15 is multiplying by 15. And what I do to one side, I do to the other. Negative 2a is equal to 120. And opposite of multiplying by negative 2 is dividing by negative 2, which means that a is equal to negative 16. Okay, so these are kind of the steps you guys can be doing. Had you guys wanted to change and make 8 a fraction, you're welcome to do that as well. It would have become 8 out of 1 to turn it into a fraction, and you could have worked that way. So another type of question that you guys are going to see is questions that involve distributive property. So before you can do anything else, you actually have to do the distributive property rule, which means that the number that is outside of the brackets needs to be multiplied by all of the numbers inside of the brackets. So 5 times g becomes 5g, 5 times 7 is 35, and that is going to equal 4g minus 12. So then our steps are the same. Step number 1, put your variables on the same side. So I'm going to move my 4g over because it is smaller. So minus 4g minus 4g. So 1g plus 35 is going to equal to negative 12. So the opposite of plus 35 is going to be minus 35. What I do to one side, I have to do to the other. So because they're both negatives, I'm actually adding them up together to get negative 47. Here's your questions. Good luck. Let me know if you come across anything that you do not understand. Have